Hello everyone, myself Mansi Kumari from BSc-IT second sem batch 2. Now I am here to prove Gauss-Jordan method. Before starting my topic, I would like to thank one of the best faculty of our college, Mr. Kundan sir, who has given me this wonderful opportunity to describe this in front of all of you. So let's get started. We have to solve Gauss-Jordan elimination method for solving system of linear equation. We have three Gauss-Jordan elimination method for solving system of linear equation. We have three system of linear equation that are the first equation is a11x plus a12y plus a13z is equals to b1, and the second equation is a21x plus a22y plus a23z is equals to b2, and the third equation is a31x plus a32y plus a33z is equals to b3. Step 1 is be the given system of linear equation. We convert this given system of linear equation its equivalent matrix form. So for converting it into equivalent matrix form, we have to put the coefficient of x in first column, coefficient of y in second column, and the coefficient of z in third column, and remaining in the fourth column. So here the coefficient of x is a11, a21, a31. So we put into the first column, and the coefficient of y is a21, a22 or a31 in the second column, and a13, a23 and a33 in the third column, b1, b2 and b3 in the fourth column. Now we convert the A1 matrix its equivalent diagonal matrix form by using row column transformation method. For row column transformation method, we have a11, a22 and a33. Its upper and lower diagonal matrix make it 0. For making a21 and a31 0, we have to follow the step 2. That the step 2 is we have to for making a21 0, we have the formula r2 is equals to r2 tends to r2 minus a21 upon a11 r1, and for making a31 0, we have the formula r3 tends to r3 minus a31 upon a11 r1. So by using the both formula, we get a11, a12, a13 and b1, and here we get the 0, and by using this formula we can change this whole row. That's why we get 0, a dash 22, a dash 23 and b dash 2, and the third is 0, a dash 32, a dash 33 and b dash 3. And now the step 3 is r3 is equals to r3 tends to, for making a dash 3 to 0, r3 is equals to r3 minus a dash 32 upon a dash 2 to r2. So by using this formula we get a11, a12, a13, b1, and 0, a dash 22, a dash 23, b dash 2 and 0 and 0, and a double dash 33 and b double dash 33. So by we have to also 0 the upper diagonal matrix. For making and a13 and a230, we have the formula r1 is equals to r1 minus a13 upon a double dash a33 r3, and second formula is r2 is equals to r2 minus a dash 23 upon a double dash 33 r3. By using this formula we get a dash 11, a dash 22 and 0, and b dash 1 and 0, b a double dash 22 0 and b double dash 2, and 0 0 and a double dash 33 b double dash 3. And for step 5 is we make the a2 a1 to 0, that are r1 is tends to r1 minus a dash 12 upon a double dash r2 into r2. By using this formula we get a double dash 11 0 0 and b double dash 1 0, a double dash 2 3 and 0, a b double dash 2 0 0 and a double dash 3 b double dash 3. So now and the step 6 is now we convert the A1 matrix form its equivalent equation form, that are a double dash 11 a double dash 11 x is equals to b double dash 1, that are that let we assume it's equation 1, and a double dash 2 x is equals to b double dash 2, it's equation 2, and a double dash 3x plus is equals to a double dash 3 it's equation 3. From equation 1 we get the value of x, and from equation 2 we get the value of y, and from equation 3 we get the value of z. By this solving we get the system of linear equation, the value of x, y and z. And now now understand this with the help of a example. So let me take a question. Question is x plus 2y plus z is equals to 8, 2x plus 3y plus 4z is equals to 20, 4x plus 3y plus 2z is equals to 60. So let's see how the question gets started. We get the given system of linear equation, its equivalent matrix form. We have to put this in the matrix form. The coefficient of x is 1, coefficient of y is 2, and coefficient of z is 1. And here coefficient of x is 2, coefficient of y is 3, and coefficient of z is 4. So that like that we have to make its matrix form. We convert the above matrix its equivalent diagonal matrix by using row column transformation method. So we have to make here and this both make zero. By we have by we use the formula R2. R2 tends to R2 minus A21 upon A11. So R2 is equal to R2 minus A21. That the value of A21 is 2 upon A11. That value is 1 upon 1 is equal to R1. So we write it as a R2 is equal to R2 minus 2 R1. And the second formula is R3 for making the this 0. R3 is equal to R3 minus A31 upon A11 R1. A31, the value of A31 is 4 and A11 is 1 R1. So by using the both formula, we change this and this raw. By changing the raw, we get now we get 1 2 1 8 0 minus 1 2 4 0 minus 8 2 3 8 2 3 8 3 2 0. We have the formula is equal to R3 is equal to R3 minus 5 R2. So by using this, we get 1 2 1 8 0 minus 1 2 4 0 0 minus 12 minus 36. And now we have to make 0 8 1 3 and 8 2 3 0. So doing this 0, we have the formula R1 is equals to we use the formula R1 is equals to R1 plus 1 upon 12 R3. And for making this 0, we use R2 is equals to R2 is plus 1 upon 6 R3. And by using the both formula, we get 1 2 0 5 0 minus 1 0 minus 2 0 0 minus 12 and minus 36. And for making A1 to 0, we use R1 is equals to R1 plus 2 R2. So 1 0 0 1 0 minus 1 0 minus 2 and 0 0 minus 12 minus 36. So we convert the above matrix it's in its equation form. So here x is equals to 1 and minus y is equals to minus 2 and minus 12z is equals to minus 36. So x is equals to y, minus cuts minus, that y is equals to 2 and minus cuts minus and 12 cuts 36 by 3. So we get the value